Google Kickstart round F starting now. Okay, let's open up a new tab because why not? Loading the round. Okay, open a problem. First one. It seems like a pretty easy problem. Just find the left and the right, and then okay. Read the string. You create left and right. And left of 0. Actually, I'll have them be size n+1. Equal to this. It's equal to r of n equal to this. And then the final answer. For the final answer, we basically just sum from, take the min of l+1 and r. So now I just need to compute this array. And all of I+1 is equal to, if it's a 1, then you don't have to move, otherwise do all of I+1. Okay, we do the same thing but from the other side. So in decreasing order, starting from n-1, r of I is equal to, so similar logic here. This should hopefully work. It's a pretty easy first problem, pretty simple to implement. Submit this and hope it works. The second problem. Seems pretty straightforward as well. So just loop through and sum the top k, I guess. K is this, D. Okay. And then you keep like a data structure that will let you sum the top k. I guess you can put it in a priority queue. Okay, cool. This worked. Let's do this problem. Read and D. What else is there? Oh, D and K. D and K, and then all of the things. And let's create, what's the maximum end here? A few times 10 to the 5th. To add, so this is, we add to, once we add it into the priority queue. Oh, we can't use priority, you have to use set. Okay, and then the ones we delete. And then we also need S and E and H. Okay, we input all of these in. Actually, I don't need S or E. Wait, I do. Do I? No, this doesn't even need to be stored. Okay. Loop through all the attractions. Read H of I, C. S and E are also equal to D. Starts at 1. Okay. to delete at the end. And finally go through everything. And you have to clear TA and TD at the end. Push this in, and then we run the algorithm. Actually, the algorithm can't be run here. I also need answer to store. It's a range of H. Okay, so it can be up to long longings. We need to store a set of all. Set S1 is top, S2 is the bottom. And then you store the set of the sum of the top set as well. Okay. So first we process everything we need to add. So now push H of A, and then sum is add H of A to the sum. If size of S1 is greater than K, we have to push something down. What do we push down? We push down the bottom one. Okay. Sum decreases by whatever value it was. Insert this into second set, and then we erase it from first set. Cool. And now max the answer with the current top set sum. Now we do our deletions. So if it's in the bottom set, then we can just erase it. HDD. Otherwise, we erase it from S1. And after doing that, if there's something in S2 and we don't have K elements in S1, also here we need to subtract the sum. Oh wait, K will always need to try to add something in. Subtracted by H of D. Yeah. If this is true, we take the top of S2, we move it to S1. Okay, I think this should work. Nothing named push. Where do I use push? It's insert. Okay. Is D a vector? Oh no. Forgot to use this. Should compile. Okay, it's on best performance. Cool, hopefully this works. Submit. So if we can find a convex hole and then see if the blue star is in it, and then that'll tell us if we can trap it. What about the smallest perimeter? It's N. 300. So we can set a starting position. Okay, this passed. So I'll just keep it open. We can have a can we use greedy? No, but we can use DP, I think. Yeah, set starting position and use an n squared DP. That seems right. Okay. You have N and then white stars and then the blue star. Just make everything longs because I don't want anything to overflow. I can make this an array of vector of rays. Read B, and then go through everything. P of I of j, subtract that with B of j. So now we just want to contain the origin. So how do we contain the origin? Oh wait. And so we'll start at, so what's the maximum perimeter? I feel like it should be lower than this. It's greater than equal to 10 to the 9. You print impossible. Otherwise you print the answer. While n is positive, in the end we'll just remove the first element. P dot erase, P dot begin. So then P of 0 will be the starting point. We have to sort everything by angles relative to that vector. Okay, I don't like geometry. This is not very fun. Sort of points Am I allowed to use P0 while sorting? I want to see which side of the plane it goes on. Can there be 3 points on the same line? No 2 stars will have the same position. But there could be 3 things on the same line. Can there? They never said you can't have 3 stars on the same line. Maybe it does not matter, but it seems like it makes it much more complicated. Or maybe I don't need to sort the thing. Maybe I just need to make sure that it's always on the right hand side of. Okay. Yeah. Okay, sorting isn't necessary, I guess. Distance d, I'll start with 10 to the 9. D of 0 is equal to 0. Repeat I minus 1 times. Try to extend. Wait, 300 to the power of 4. How much time do I have? 50 seconds. Times 10 divided by 50. This is definitely not. Okay, maybe this is doable, I'm not sure. I'm working with doubles. Probably don't want to risk. I know, this is just finding the minimum cycle, right? Which I can do with Floyd Warshall. Then did I have it? Okay. How do I use this again? calculate distance from I to J. With K in between. If I is equal to J, I guess. It's equal to a minimum of d of I of k plus d of k of j. And is my recording working? No, it stopped. Looks like my camera is not working, so I'll just have to continue from here. We need to find these distances. Well, you need to initialize the distances, right? And then we min di of j with di of k plus dk of j. So, question is, can we, which side is it on? You have I here, you have J here, and we have the origin. And then we just have to enforce one of the directions. Okay. Then it'll be phi 0 times p of j of 1 minus p of I of 1 times p of j of 0 is greater than 0, then it's just is this even a function? 0 minus p of j of 0, p of I of 1 minus p of j of 1. Let's compile this. Oh, they're different. Shoot. Guess I'll need an if statement here. Both of them give 0. Looks like I'm not doing this yet then. K is not equal to I. Okay. Maybe this will fix it. Okay, so this turned out to be a stupid graph problem, maybe. Let's hope I got this right. And then graph travel. Let's open this. How many ways? What's in an M? 15. 15 factorial is definitely too big. Yes, this is like 2 to the 15. Okay, cool, this passed. Or maybe 3 to the 15th. Between L and R. Collect K. Exactly. K magic points. That's interesting. So we need the set of rooms we already visited. What else do we need? Do we need anything else? Let me just choose some room to break into. Right. Oh wait, we have to travel. Visit the room in the order. Oh, the unique path. The order in which you break the shields. This seems like pretty simple Bitmask DP. So, okay, I can write this. NMK. And then end lines. ORNA. Event. And then we have the edges. I should read this. I'll use a Boolean matrix for this. Then I basically fill in the adjacency matrix with input. And now I can start the DP. Wait, 15 factorial might just be the limit for long longs. DP. 1 to the nth power, 2 to the nth. So what do we start with? Start with any room. DP1 to the I has exactly one way. Okay. In pop count I, it's less than 2, then it's a base case, so we just continue. We need exactly K points. Collect. Okay. I also need a subset sums of all. Okay, so I'll pre-compute the sums of all subsets. J1 to the I plus 1. What happens is, wait, is it 1 to the I plus 1? No, I think it's 1 to the I. Okay, dpj plus 1 to the I is equal to dpj plus element I, which is a of I. Okay, and then, oh no, this is S, the sum. Shoot. S, okay. If S of I is equal to K, then we add number of ways to get this to the answer. Cool, so now what we do is current state. Go through all states. If we can reach this state, okay, and then if we cannot reach this state, and we have not reached this state yet, but can't get this from. Actually, we need a boolean of reachable states. Can reach, and we do what we just did. So if we can reach this, we cannot reach this, and also there's an edge, and we satisfy the inequalities. So L of K less than or equal to S of I, and S of I less than or equal to R of K. Then we can reach K. And for all K we can reach. Oh wait. Never mind. I'm gonna use push DP here, not pull DP. So I'll just block these out. Might as well move this here. 4K, okay. DP of I or 1 to the K, so include K. Add that with DP of I. Cool, this shouldn't be too hard. And it crashed for some reason. Oh wait. If CR of K. I don't think that's the reason why it crashed though. Let's try this. See where it gets. 0, 1. Wait. So what's going on here is reading RA. Makes this. It tries to read this. It's the first one. For some reason it's numbered 0 and 1. What? Okay, so this was unnecessary. First time I saw 0 indexing already in a problem. So that was a surprise. Wait, I should remove this. Two, 2, 4. I'll just stare at a code until I find something. I can use OR for this, whatever. S of J plus A of I. It's L, R, and A, right? DPI. Okay, let me just try the ways. First case. I don't get this. Why does this go here? Room 2 and then you can also start in room 1, right? Get 1, go here, you get 2, and then you go here. Okay. Wait. So 7. I'm going to try to debug the first case. I think I missed something. Yeah, these 3. 1 1 2 1 7 0. But 3 is 0. Huh. What if I said this is true? I think it'll. Oh no. Why is the answer 1? Oh wait. Read them in the wrong way. Shoot. This probably fix it, hopefully. 4 cool. 40 minutes. I think I could have been faster, but I think it's pretty good as well. Cool. And then a lot of people solved it really fast because this went easier round. Fifth, okay. I have no penalties, so I think I should stay 5th. So, pretty good round. Okay, I'll see all of you in the next round, round G.